to you guys right now about covalent compounds. We talked previously about naming ionic compounds. I told you guys that you recognize those when you got a metal and a non-metal. Alright? So if that's how you can recognize an ionic compound, covalent compounds are simply those that don't have a metal in them. Alright? So distinguishing between ionic and covalent is really just a case of recognizing, can you tell whether or not you have a metal in your compound? It's not particularly involved. Now for naming these, the rules are different to how they were for ionic compounds. Alright? When you did ionic compounds, like for example CaCl2, we said that was just calcium chloride. The name did not reflect the number of chlorines in the molecule, even though you knew how many chlorines were there. When we talk about covalent compounds, we actually do have to take into account how many of each atom we have. And that's where these prefixes come into play. Now by prefixes I mean mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, that sort of thing. The way the naming goes, the first element is the easy one. You just name it with its name. Phosphorus, sulfur, hydrogen, carbon, hydrogen, boron. The second element, you name it as if you were naming it in an ionic compound. Oxide, chloride, oxide, oxide, fluoride, fluoride. Alright? So that means then, at least on a basic level for this guy, phosphorus oxide. However, because these are covalent compounds, we have to make sure we do dictate how many of each are present. That's where our prefixes come in. The prefix for 4 is tetra. So therefore, tetra, phosphorus, you remember we don't do anything to the first name, tetraphosphorus. Now the prefix for 10 is deca. Therefore, deca, you just put the prefix in front of the name you're going to use. You remember we said you name the second element as if you're naming it in ionic compounds, oxide, chloride, that sort of thing. Tetraphosphorus, deca oxide. So the tetra tells us we've got 4 phosphorus, the deca tells us we've got 10 oxygen. Alright? Now, I started off with the most involved one of the bunch. If you can do that, you can do all the others. SCl2. Alright? Well, I'm hoping everybody can see that for the chlorine you're going to need di because you've got 2 chlorines. Before we do this one, I want to go on to this one. Alright? Everybody knows what the name of CO2 is. Everybody knows its name is carbon dioxide. Alright? Carbon dioxide. Oxide tells you the second element is oxygen, carbon tells you the first element is carbon, di tells you there are 2 oxygens. Alright? I said before the prefix for 1 is mono. So why don't we use it in front of carbon? Why isn't this mono carbon dioxide? Well, there's one exception to our rule here. If you have one of your first atom, you don't put mono in front of it. You put it every other time you have one of your second atoms, but you don't put it for the first one if there is only one. That's why this is carbon dioxide, not mono carbon dioxide. So for the same reason, this is not mono sulfur, it's just sulfur. So therefore, sulfur, we know this is going to be chloride, and because there's 2 of them, it's going to be sulfur dichloride. When we come down here, everybody knows, I hope everybody knows this is water. But if you want to get all technical and sound like you know what you're talking about, you can call it by its technical name. There are 2 hydrogens, therefore dihydrogen, and there's 1 oxygen. Oxygen, of course, is oxide. One of them, you put mono there. Dihydrogen monoxide. So if you want to freak people out at home, tell them, will you go get me a glass of dihydrogen monoxide, and just see what they say. Or maybe when you're walking around campus or whatever, you can say, everybody be careful, I have a bottle of dangerous dihydrogen monoxide here. and then maybe people will just say, you're weird, stop talking. Anyway, let's come on to this one. HF. This is actually known as hydrofluoric acid. However, we haven't seen acid yet, so we're just going to name it as using these rules. We have one of each atom, so the first part of the name is going to be hydrogen, and technically hydrogen monofluoride. Alright? And then down here, B is boron, F is what it was before, fluoride, but there's three of them, boron trifluoride. So really the key here is just remembering the prefixes that you didn't have to do for ionic compounds. Alright? And when we go the opposite way, we just got to remember the same thing. Carbon monoxide. Well, of course, this tells us we've got C. The fact there's no mono here or anything else tells us there's one carbon. Monoxide means one oxygen. Everybody knows what carbon monoxide is. Xenon hexafluoride. Now, this, of course, tells us there's fluorine. This, of course, tells us there's xenon. But what does hexa mean? Well, hexa, like hexagon, is a prefix for 6. Therefore, 6 fluorines, XeF6. Diphosphorus pentasulfide. Well, let's just break it down. Sulfide means we've got sulfur. This penta means we've got 5 sulfurs. Phosphorus, of course, means we got phosphorus. Di means we've got 2 of those. So therefore, just put all that together. 2 phosphorus, 5 sulfur, diphosphorus pentasulfide. Alright? So you can see naming covalent compounds is less of an issue than naming ionic compounds. The rules are very simple. Plus, there's no polyatomic ions to worry about. That's what makes naming these a lot easier. Anyway, that's how it goes.